Well, thanks very much for having me here. I get lots of invites to conferences, and there's actually several competing for my attention this week. But I know said that last year there was some kind of survey of who they wanted to have in Chicago this year, and I was somewhere near the top of this survey. So you can't turn down that kind of prior approval or something, whatever it is. But so that's why I'm here. I thought that I haven't been to Chicago for a while, and this is the GOTO series of conferences are excellent conference series. It was in Aarhus a few years ago. I'll be there again in this year. So anyway, what I'm going to talk about today is the nature of innovation and the reasons why we use innovation to go fast and go and scale things, and then some of the examples, and then get a bit more, other than sort of explaining why this matters, also talk about how you get there, some more practical things. So I've got a whole hour, so I've got quite a lot of slides, and hopefully I'll make it through this. So what have I been doing the last few years? And this is kind of my instant summary. I've been out there baffling late adopters as a service. I've been out doing conference presentations, and mostly to people go, over the years, people got slightly less confused, but definitely what Netflix was doing was baffling to what most enterprises were doing. And over the years, this changed. So the reactions to my talks, 2009, Netflix started going to cloud. We started a few things running in the back end. We weren't actually running any public-facing things, but we were getting our feet wet, and we decided this looked like it might work. And when we said we were going to move all of Netflix to cloud, everyone said we were completely crazy. They didn't even believe we were actually doing that. They thought we were just making stuff up. And then during 2010, it moved on. I started doing some presentations in late 2009, early 2010. And in 2010, we were doing... They agreed we were actually trying to do it, but basically assumed that it wouldn't work and we'd be back in the data center pretty quickly, tail between our legs. No, sorry, that was a bad idea. But for the beginning of 2010, there were actually none of the customer-facing stuff was running in the cloud and Netflix. And the first piece went up in January, and then by December, all of the customer-facing website and most of the API calls were actually being served out of the cloud. So during 2010, we moved everything to the cloud. And so after that, they said, well, okay, I guess it is working, but it only works for these weird unicorns like Netflix, and it's totally irrelevant to anything that anyone else has ever done or ever will do. You're unique. So that's when I adopted the Cloudicorn as my mascot. I have a little unicorn kind of cloud thing. There's a guy in Denver that made that little icon that I use on my Twitter feed, and I have a T-shirt of it as well. So during 2011, we had the front end, the customer-facing stuff, but it was still back-ending into the data center, and this is what most people call hybrid cloud. And there are people that think that hybrid cloud is the end point, and it's a happy place to end up. Netflix thinks of it as something like Roman riding, which is Roman riding is a rodeo trick where you have two horses, and you're standing on the horses with one foot on each saddle, holding a pair of reins in one hand, a pair of reins in the other hand, jumping through hoops of fire and doing tricks, right? And the only thing connecting the horses is your legs, right? And if the horses decide to do this, you land on the ground in a pile of dirt and uncomfortable, in a very uncomfortable manner. So a lot of outages in that time period were caused by the data center and the cloud not quite being in sync or losing the connection or something that mostly the data center broke the cloud. Occasionally the cloud broke itself, but almost all the outages that actually happened were caused by trying to run hybrid cloud. So that's my kind of warning. If somebody thinks that hybrid cloud's a good idea, go worry about how you're going to make that work reliably. So what actually happened during 2011 is Netflix moved its back end from the system of record from being Oracle in the data center to being Cassandra in the cloud. Prior to that, they were using SimpleDB. And so at that point, pretty much everything is now owned in the cloud, and there were backups happening, and what's going on in the data center is sort of an appendage, still a few things running there. So, we kept going. I kept doing more and more talks at conferences, and people were going, okay, I think actually this does look useful, but the gap from where we are to what you're doing is just too big, right? Okay, that looks nice. It has all these nice features. It scales, it's highly available, it's got agile development, but it's, I'm baffling late adopters, right? They can't figure out how to get there. So during 2012, Netflix started open sourcing stuff seriously, and like Dave said, we've, I think, over 40 projects, 42 projects, something like that right now. I may have done a few more in the last few weeks. And so as I went out, what I found was that people were, I started running into people that were using the Netflix code. So during 2013, I'd be going out doing similar kinds of presentations, but half the audience were actually using some Netflix code. Now, how many people here are using something from the Netflix code base? So we got a few. Well, thanks for that. And it sort of moved on to, okay, we can see some aspects of this are the next generation of applications, and we're trying to understand it, and there are other people simultaneously coming up with other architectures. So it wasn't just that people were adopting what Netflix did, but some of the concepts, some of the cloud-native concepts started to become common in other areas. So there's now several different ways of doing this. The Netflix open source code really helped bridge that gap. So what I learned from my time at Netflix, one of them is that the whole architecture of what Netflix does as a business is oriented around speed. So Netflix, 7 years ago when I joined Netflix, it was a tiny company, roughly $1 billion in revenue, and it was competing with some of the biggest industries and the biggest players in the market. And when you're tiny, the only thing you can do is dodge faster. Right? So the faster they could move, the more they could confuse the competition, and the more agile they were, the more able they were to actually disrupt things. And they've been extremely successful at doing that. I still think that, I look sometimes at what startups come to, talking to startups nowadays a lot, and they say, we're going to develop this thing, and we're going to put 3 engineers on it, and it's going to take a year. And I look at it and going, I'm sure someone at Netflix built that, like one guy built that in 3 months. There's an incredibly productive development model at Netflix where ridiculously large amounts of stuff are built by a very small number of people in a very short time span. I've never seen anything be built. So you'd ask somebody to do something, it'd get done sooner than you expected it would happen, and that never happens in software, right? So what they do is to get there is basically take all the friction out of product development. And you do that with a high trust, low process, with no handoffs between teams. And I'll talk more about that later. And you need a culture that does that, a freedom and responsibility culture, which is basically also, you can think of it as a high trust culture. And then the other thing is to aggressively get rid of anything that isn't core and isn't innovative and that is becoming commoditized. So that's, don't do your own undifferentiated heavy lifting. Don't build your own data centers. It's a big distraction. Somebody else will do it for you. And then from an architecture point of view, rather than trying to impose architecture on everything, I was sort of chief architect after, somewhere in 2010 I became chief architect. The idea was to use simple patterns and automate them with tooling. So you document the paths that work. You don't prevent people from inventing new paths. So there's a little bit about creating a path of least resistance for by automation and tooling, but not constraining everybody to follow it. So it's kind of a carrot rather than a stick approach. And then finally, moving to self-service cloud took a whole bunch of things that used to be impossible and made them instant. And you can deploy enormously large infrastructure for experimental purposes for a weekend, and there's some things that you just could never even think about doing in a data center-based environment. I need 200 terabytes of SSD. Who can get that in 20 minutes? I mean, if you have a big enough AWS account limit, anybody can get it in 20 minutes, right? Maybe you have to be able to get enough instances, but that's really all it comes down to. So so what's going on is Netflix and a whole bunch of other interesting leading companies like Twitter and Facebook and Google are all on this leading edge curve, and a lot of enterprises are falling a bit behind. So this is kind of what this looks like. This is Simon Wardley's Simon Wardley diagram. So here's the adoption of cloud and rest of world, and I'm on this green line, and the rest of the world is on this, no, ignore, no, I said no, damn it, oh no, and then I had to cover up the word. But what's happened now is that the rest of the enterprise is actually, we're in this now point, where I say now, we're somewhere in this point now where enterprise is now rapidly converging. And this gap between the early adopters and the incumbents. So this is the sort of disruptive people are on this green line tracking it, and the incumbents are on this red, the orange line there. So this is really interesting, and the gap here is what became interesting to me. So as everyone else suddenly starts trying to catch up, it became what I basically decided was that by leaving Netflix, I could go out and engage with all of these large enterprises and work with all the companies which are exploiting this gap, right? So I'm talking to SaaS companies and enterprise IT companies that are trying to figure out how to help enterprise make this change. And there is a huge change going on in enterprise IT right now as they retool for continuous delivery in cloud and DevOps and all of these kinds of things. So that's kind of what I'm up to and why I'm left Netflix to go work for Battery Ventures. So I'm going to talk a bit about the nature of innovation. And what we're really talking about here is speed. And what are you trying to speed up? Well, you're trying to speed up the innovation. And what do you mean by innovation? So innovation is really about having new ideas, and that new idea, you want to turn it into a new product. So there's products on the incumbents make new products all the time, and disruptors make all products all the time. So what's the difference? What is the difference between a disruptive new product and something coming out of the incumbent, the old world? What it really comes down to is the assumptions you're making. They're making different assumptions about what is going on in the world, and then they're optimizing their business model for those assumptions. And the problem is, this is a really good quote, it isn't what you don't know that gives you trouble, it's what you know that ain't so. So what the incumbents are doing is they're making an assumption that is no longer true, and they're optimizing their business model for it. Maybe it used to be true when they originally made the assumption, then they built a business model, they optimized around it, and they've been going down that path ever since. And the trick here is that if you spot something that everyone thinks is true that isn't true anymore, then you can disrupt them. Now, how do incumbents really drive their business? What they do is they follow the dollars. They say, it's fine, we still own 90% of this market, these disruptors are only 10%, we're fine, right? The trouble is that dollars are a lagging indicator of market. What happens if the replacement technology is 10% of the cost, right? Now you're in a 50-50 market point when you still own 90% of the dollars. Right? But or if the replacement cost is it's open source, maybe it's free, right? How do you measure replacing a multi-billion-dollar market with something that's free by looking at the dollars? You just see the dollars magically shrinking until there's nothing left. There's no market to adopt. So what you're looking for is the disruptors are finding something that used to be expensive, right? And then you learn to waste that expensive thing that used to be expensive to save money on something else that other people can't do. So quite often you're wasting what used to be an expensive resource to save yourself time in somewhere else. So I'll give you some examples to make this a bit clearer. And one of them is a really easy example, solid state disk. Right. Solid state disk replacing regular disks. Decades of research into storage subsystems. Like all of those academic papers on elevator seeks and B trees and all of these layouts on disk are basically to get around the fact that there are bits of metal moving around and spinning rust, right? Head movement and spinning rust. And it's decades and decades and decades of research into everything optimized around old style disks, where random reads are horribly expensive because you have to move metal to actually get there. But on solid-state disk, random reads are basically free. You can do as many of them as you possibly want. But updates are expensive. And so what you actually want to do in the new world is you've got this world where random reads are free, immutable writes are low cost, but updates are expensive. So you end up wanting to build something that's more of a log merge file system. And there's some research into this, but almost all this technology we're using is not built for this new world. There's also been some changes in packaging. So if you think about solid-state disk packaging, first of all, they just put it in something that looked like a disk. So that's what you have in your old-style laptops and the original solid-state disks. They came with disk interfaces on them. And then people said, well, we don't really need that disk interface. We can jam it on a PCI card and put it on the I/O bus. And now They're going, well, actually, you can just stick it on a DIMM card and put it in the memory. And one of the, I didn't used to worry about hardware for the last few years because I was at Netflix and they don't care about hardware. But a battery this is actually a battery investment, is this memory channel. So now you get a memory DIMM with a few hundred gigabytes of solid state disk on it. And the memory bandwidth into this is ridiculously high, and it's so fast, and it's so low, and the cost is low, and you're just using unused memory slots that you would normally put RAM in, you're putting solid state disk in them. So this is just moving closer and closer, and you can't get a piece of, a physical disk and stick it in a memory slot. That's not going to happen, right? Right. So this is a technology you couldn't do. So what happens when you bring solid state disk into this world? So there's a couple of different ways. The traditional storage architecture looks something like this. You've got your business logic, some kind of master-slave database with some sort of replication between them, a fabric, SAN fabric, network, Ethernet, whatever, and a bunch of storage arrays with disks and maybe a tape drive off at the side. So that's traditional. And you're putting solid-state disks in the bottom instead of spinning Rust. The new model, though, the kind of thing that Netflix is running on with Cassandra, they're just nodes, and the memory's in the nodes. I mean, I don't really care how the memory got into the nodes, whether it's DIMMs or disks, it doesn't matter. But I don't know. You just get these things from AWS, and they have disk in them, and they have lots of SSD. We do backups to Cloud Object Store, so I don't even know where that is, but you can sort of spread these things around, and it's very cheap, so I don't need tapes either. So what's going on here on the left? You get people like Pure Storage disrupting EMC by optimizing their whole business model around solid-state disk. So that is actually quite interesting because they're able to do things by optimizing solid-state disks, and they're disrupting that piece of the storage industry. If you look at the right, there's no SAN management software, there's no storage management software, there's no SAN admins, no DBAs. There's a whole stack of people and management tools and technologies, and there's a multi-billion-dollar business in the stacks on the left. In the right, I got an instance from AWS, I ran some open source software on it. The admin on the right is a Java distributed systems developer who understands how Cassandra works. Okay, there is no other admin ops people there. To keep Cassandra running, you probably need some people that just dedicated to keep updating it and things, but they still need to be Java distributed systems people rather than SAN admins. So this thing on the right contains no revenue at all for the traditional software vendors. I did this at a storage industry conference, and there were a few white faces in the audience. It's disrupting an entire industry, and there's thousands of instances running at Netflix like this that replaced what used to be a big data center with Oracle and SANs and stuff like that. So, but they probably say, yeah, but maybe it doesn't scale. Well, no, it does scale. It scales beyond ludicrous, and I'm going to show how that works. Cassandra scalability. I ran a whole bunch of benchmarks over the years. It scales up. It scales linearly. In the benchmarks and in production, if you want more capacity, just double the size of the cluster, you get double the storage and double the throughput. It's very, very linear. Netflix runs 288 nodes. There are other people in production running hundreds of nodes. It's just, that's known to work. It's in common use. There are a few people running 1,000 node clusters, and there is testing going on in the scale in the 1,000 to 10,000 range. I was talking to the DataStax guys, Patrick McFadden, and he said they are actively going to test 10,000 node Cassandra clusters because they have customers that want to do that. And I have no idea what they would want to do that. But so that's thousands to 10,000s of nodes. Well, multiplied by what is a node? Let's just look at what we could build this out of. So let's use the highest end current AWS instance, and some of you may know this, but they came up with this thing called the i2-8X large. It's got 6.4 terabytes of SSD, and it does over 300,000 IOPS. That's one node, right? That's already kind of pretty good, I think. So let's do 100 of those. Well, that's 30 million IOPS and 640 terabytes. That's ludicrous, I think. And then let's just do 1,000 nodes is plaid, basically. So there we go. We got a plaid here. Light speed, ridiculous speed, ludicrous speed, we go to plaid. So it's a Spaceballs reference for those of you that haven't been watching movies for the last 20 years. And so it's It's crazy. You couldn't possibly need that much capacity. So I think we've got Cassandra is disrupting things here. It's got you can do global distribution. You've got high availability. You've got there's ridiculous scalability. So that's an interesting sort of example of how solid-state disks and open-source software are disrupting a whole industry, and the rest of the industry is still assuming that you need to hire storage admins to look after these things and have SAN fabrics. So let's look at product development now. And I think, who here has a product development process? Yeah. So why do you have a process here? What is the assumption you're making? I think you're assuming that you have a process to prevent problems from happening. Right? And the more problems you have, the more process you will have. And you keep going around that loop until you become a really big company where you can't get anything done because you have so much process, but that it prevents problems happening. So this is kind of what product development looks like. You have a business need, so you spend weeks documenting it. Then there's an approval process that takes weeks. And then you go and argue with hardware vendors for a few weeks. And then you write software for weeks or months or whatever. And then you start deploying it. And that takes a while, and then customers eventually say it sucks. And this is about 9 months later or something like that. So we want to speed this up because you don't want to find out a year after you started building something that your idea sucked. You want to be able to speed this up. So let's put some infrastructure as a service in here and replace these two steps with an infrastructure cloud. So it's a bit quicker now. So now your process looks like this. You've got a product manager, a development team, QA team, ops deploy team, and business analytics. So you've kind of got rid of that facilities management and hardware ordering stage. And your process looks a bit like this. Oh, yeah. So it's a bit better. And you can get all your hardware from basically off public clouds, private clouds. I just put up some examples here to give you the idea of what I'm talking about. All right. So that makes sense, but it's still taking months to get stuff done, or maybe weeks. Maybe you sped it up to weeks. Still fairly slow. So a lot of people are just happy that they got this far. So let's see if we can speed it up a bit more and replace this software provisioning piece in the middle here with a platform. So we put a PaaS cloud in there, we take out this chunk, and now we have a product manager talking to a developer who deploys their own code to production somehow, using the platform, and then the BI team measure what happened and fed it back. So now you're going a little bit quicker, and there's lots of possible platforms here. I've got a few things you might recognize. Continuity is a sort of a Hadoop-based platform, and so the rest of these are mostly just standard development platforms. So now you can get around this loop, but you're no longer doing an entire product. You're not sort of gathering together the work of 100 developers and every 2 weeks and making this massive mega bundle which QA beat into shape, and then finally the train goes and you stick your code in and then you find it's broken and back it all out because one piece of it was broken. Instead, what you're doing is feature by feature. Everyone's deploying a feature at a time, independently. And that sounds a bit more chaotic, and we'll talk a bit about that as well. But what we've got now is we can get around this in a few days, and you can turn around an entire product idea to get the feature into production in maybe a week, end to end. And if it's just a fix or something like that, you can probably get stuff out the same day, because there's no handoffs left in here. So, but it turns out a lot of people build the same products over and over again, particularly internal apps for business. Right? How many people have payroll? Every company has payroll. Okay, so years ago, like ADP and people like that just did payroll as a service, and now everyone uses ADP or companies like that. So this isn't a new idea that you would want to just have a standard business app. But that's really what SaaS. So think of infrastructure as a service as ops people no longer having to talk to facilities people and hardware vendors, right? So you've just cut out that whole area, but you still have ops people running your cloud. Once you get to platform, the ops people have been replaced by an API. Well, they're still there, but they're behind an API, right? From a developer's point of view, they call the API, and it doesn't really matter whether it's an internal or an external API. The ops is happening behind that API. So it's ops people no longer having to have meetings so it's developers not having to have meetings with ops, it's platform. Now, if you have business people that don't have to have meetings with developers, that's SaaS. So let's replace the whole development bit with some SaaS kind of thing. And now you've got a GUI builder or configuration tool, and there's your product. And if you got a link wrong, or you don't like the color, or it doesn't do what you want, you push some buttons, and 10 seconds later it changed, or whatever. So there's a few people in this area. There's lots of them. Salesforce have a lot of optimization. There's a platform they have for building apps that's like this. There's Mendix in the sort of, it's kind of building internal apps. There's Platfora for building big data apps. The Enterprise Web, be up later, doing something similar to this. And then there's all of those actual apps that actually do things where you're just configuring it. And pretty much every app now is delivered as SaaS. If I look at the battery portfolio, 90% of them are SaaS. But the loop now, it takes seconds to change something. So what's actually happening here is that over and over again, we're reducing the cost and the size and the risk of the change, and we're able to increase the rate of the change. So that's the trick. So what does this look like if you're doing continuous delivery on cloud? We're trying to get around this OODA loop. To start with, we're trying to observe something. So we'll call this the innovation piece, right? We'll see a land grab opportunity. We're going to take over the world. So Netflix is just taking over country by country by country. Or you've got a competitor, you saw a competitor do something, you want to respond to that. Or you see 3 or 4 bug reports that sound kind of similar. Maybe there's a customer pain point. So next thing you want to do is some analysis. You want to go dig out from the logs all the customers that have that same error, all right? And so the key point here, and they call this big data. The difference between big data analytics and the old style business intelligence is the old BI side was about, okay, there's a report I know I'm going to need every week and it needs to be accurate, so I will spend months crafting that report and validating it, and then I know how much I sold last week. Right? Your weekly sales report is a BI report that has to be accurate, and you know you're going to need that. What I'm talking about here is rummaging around in log files that no one's ever looked at before, crossing together combining together all kinds of data sources. And so the speed at which you can answer a question that you've never asked before is what matters in big data. So think of it as how quickly can I get to an answer for something I've never asked before, and hopefully the developer themselves is enabled to go and ask that question, or maybe with the help of an analyst. Then you're going to plan the response. You're going to just do it because you just have APIs and you're a developer. And then you're going to share that you're doing it, because you don't want to just hide away and do things, but you have to share. But you're not asking for permission. So this is part of the culture of freedom and trust that you need to go fast. And you can get blocked up on this level. And we'll look a bit about DevOps in the next few slides. And then finally, you're using cloud to incrementally deploy one feature at a time. You're doing automatic deploy. The way Netflix currently works, you check code into the repo. That code, if it works, will automatically end in production everywhere in the world over the next day or two. It just flows out, goes through some automatic testing, canary signature analysis, and that's it. Right? There is no push process. I checked this code in. If I put code in the repo, it's because I think it's safe to put it in production. Right? That's the mindset. And they have most of their large teams using that model now. They specifically decided not to have the email, are you sure, checkbox thing in there. Right? And I got some questions about this from Andrew Spiker yesterday on Twitter, so I thought I'd put a slide in to just be really clear here. What you're doing is launching code usually behind an A/B test or behind a feature flag. So it's a non-destructive. And so you're adding code into the system, but you're not removing the code that's already there. This makes it incredibly safe to put stuff in production because you have this immutable code pattern. So you don't change anything. When you add new code, you add a new instance running the new code. The old instance is still there. So the old code's in service, so the old traffic and the customers are mostly going through the old code. So the fact that you put new code into production didn't take anything away. It doesn't cause bugs. It only impacts anybody that gets to see the new code, but it's behind an A/B test or a feature flag or a version flag. Right. So you launch your new service as your brand new experiment, and you put yourself in the A/B test cell for it, and then you keep revving the version of that with your code pushes until it looks like it works well enough to point your QA or some other people or some internal test users at it. Maybe the product manager ends up going to say, yeah, that new feature looks like it works okay, and everyone's happy it works, and then you allocate a bunch of people into a cohort into that test cell, and then they start working on it, and you've got another cohort of users in the regular previous experience, and you evaluate whether it's better or worse than before, and then eventually you shut down the old version and switch everyone into the new version. So you make the feature default, and then eventually, much later, you remove all the old code, you shut down the old instances, and you remove the test that redirected everyone into it because it's become embedded. So it's incredibly safe to push to production. Everyone's creating their own little features, and each of these features, if you do it right, if you put these features in one big monolithic block of code, it's a little bit more scary, but if you have microservices, you're really creating a lot of isolation. So the disruptor here is continuous delivery, and getting this right means you can run incredibly quickly, and you can innovate incredibly quickly, and you can learn and you can get customer feedback in a statistically significant way in weeks, rather than spending years or months or quarters or whatever to find things out. Okay, let's think about developers and operations here. And the assumption that most people make is that devs do one thing, ops do another thing. They're different, and you have to there's these sort of real reasons why you keep a barrier between them. And that's because developers make code and operations run code. But the trouble is the developers are grumbling because it takes them weeks to get a VM. Right? I've heard this from some of the biggest companies in the world that have the biggest IT budgets in the world, and they should be able to have the best service, and they have some of the worst service. It takes 60 to 90 days to get a VM from filing the ticket because of all the handoffs. But what we're talking about here is making operations into a self-service API for those developers. Now, the ops guys are still there building the platform, running it, building these APIs, operating something, but it's a mixture of internal APIs, external APIs. So there's still stuff to be done in operations, still a massive amount of innovation there. But the boundary between development and operations becomes an API, which means it can be automated. And developers are now running their own code in production. That means developers are on call. Okay? And you're giving them freedom, but you're also giving responsibility. But now you have incentives to be responsible because you don't want to be woken up at 3 a.m. And there's a fundamental difference here between what happens is if you give a production process to a bunch of ops people, they will automate that process. That makes sense, right? Well, give it the same process to a bunch of developers, they will remove that process. They will automate it out of existence, right? So I don't see what, I can just, if I change my app and I build some automation on here, that process just collapses to nothing. I've seen that over and over again. That's the difference you get. I'm sort of over-characterizing between ops and dev, and there are a lot of people somewhere in between or experience of both, but that's kind of the caricature mindset, right? Instead of automating a process, streamline it, remove it, shrink it out. But what you tend to do then, particularly if there are people making money at some step in that process, you've got a product in that process, or you're using a product, the people that sell products always want to increase revenue for their products, so they want them to automate more and more of the process. Whereas developers will design out entire classes of products. And that's what you saw with my Cassandra example earlier. The developers designed out all of the operations and storage management stack completely. That's a clear example. So you think, yeah, but developers are going to keep screwing up, and so you'll have lots of outages, so they'll go running to the ops people to fix it. But it turns out the developers, there's actually less downtime in this because the developers build code that doesn't break. And the developers that can't figure that out eventually kind of get to go work somewhere else where they can't hurt things. And you hire people that can figure this out, and it becomes a self-selecting thing. And some of this comes down to having the right incentives in the system and having externalities and problems with that. So there's this, this is an old idea, but instead of having an airbag in a car, which makes everyone drive too fast and get into accidents because you feel safe because you're surrounded by airbags, if you put a 6-inch steel spike in the middle of the steering wheel on everybody's car, there would actually be fewer accidents on the road because everyone would be so careful. Right? So think of the fact that your code is in production and you're on the PagerDuty as every developer having that 6-inch steel spike that says, if I hit push on this code, I could get that call this weekend when I want to be out hiking with my family, right? So I'm going to think twice about whether that. But if you've got an ops guy, throw it over the wall, he'll get the call this weekend, he'll probably know how to fix it. So you end up with a higher quality production because of the automation and because of the peril involved in doing it is actually, you've tightened this feedback loop. So you're avoiding the creation of these externalities. And then you think, well, yeah, but you're spending all this time doing it. But it turns out that weekly meeting you have or that daily meeting you have, depending on how fast you're going to go, to explain to the ops guys how your code works, and mostly it just works, but you still have to have the meeting in case it broke. Okay, this is the current state of my code in production. Yeah, you've got to have that regular meeting. Well, if you don't have that meeting because you're doing it yourself, you just saved a lot of time. And it turns out that you spend more time explaining to operations how your code works than you spend on call fixing it. So yeah, you still get woken up occasionally to fix it, but it actually works better this way. So this is a little bit counterintuitive. Again, this everything you know is wrong kind of thought that you can have developers operating stuff in production, and it is more reliable, and it is less time for them to do it. And that's the experience we got at Netflix. Now you still have to get there, and we'll talk a bit about that. So DevOps is a reorg. Right? It's like all the DevOps people keep telling you, if you created a DevOps team, you're making it worse. It's a reorg. It's not a new team to hire. And one of the problems here is that that's a big cultural problem. So this is really the underlying disruptor. Building a high-trust culture and getting the sort of DevOps model in place, that's something that's very difficult. I saw a tweet yesterday where somebody said, is DevOps ready for the enterprise? Or they didn't think DevOps was ready for the enterprise and said, no, that's backwards. Yeah. There's a bunch of enterprises that aren't ready for DevOps, and they're the ones being disrupted by the enterprises that are figuring out how to do DevOps, right? If your enterprise or what your organization is capable of this kind of cultural disruption, you will be the early adopter, the leading innovator, because you can go so much faster, and whoever isn't able to do it is going to be left behind. And that is why you're seeing enterprises now trying to adopt DevOps, because they see that as agility as a competitive advantage is what's driving them. And you're hearing this more and more now that agility is important. If you go to any CIO and say, or any organization say, would you like your products, your software products to take longer to get out? No, nobody wants them to take longer. Would you like them to be quicker? Yes. Okay, so this is how you make them much quicker. So it's what you know that ain't so is the problem. And you keep running on these old assumptions, and eventually you go off the cliff, and as long as you haven't looked down, you don't actually fall into the canyon like Wile E. Coyote. So how do you avoid that? First of all, these assumptions that you're making, make sure they're explicit. Think really hard about the assumptions you're making, and then think about the trends in those assumptions. Is this thing that is currently expensive, is it gradually getting cheaper? Is it getting cheaper? Is it suddenly going to get cheaper? Is it about to be replaced by some technology that obsoletes it? Think about that. The other thing is, if you're a vendor, listen to people who aren't your customers, right? If you're a big database vendor, yeah, my database customers are all buying my database. That's great. But what about all the people that you never hear from because they're not buying your product? You need to understand why they're not buying your product and what they're doing instead, and then you can understand how quickly you're being disrupted. Developer adoption is a leading indicator of a product move or of an innovation, and dollar spend is a lagging indicator. So if you hear people saying the market is blah and we're okay because of the dollars, they're following a lagging indicator. If somebody says, hey, look at Docker or something, which has this great developer ecosystem, and look at how many committers they have on their project, that's a leading indicator. That tells you that that's going to be something. But the dollars in Docker right now are tiny. But in terms of, is it significant as a leading indicator? I think it is. And then you've got to look at the evolution. Things that were leading edge products become services, and then they become utilities, and they become less and less interesting. Push them out, stop doing them, concentrate on the innovation stage. Unless, I mean, if there are companies whose business is to optimize a utility. I mean, you still need those companies, but they're less interesting from product development point of view. And then you have to reorganize your teams for speed of execution, and that usually means creating a sort of a vertically integrated team. So Amazon call this the two-pizza team that owns everything about a product. You've got the product manager in there, you own your own data sources, you have a high-trust small team that is able to go and build something. And everything outside that team is a sort of accessed via an API, which is sort of untrusted. You kind of, you can't, and the internet works like this. If you're building a typical application, let's say a mobile app, it probably depends on tens of different APIs from across the internet. Might have a bit of Google Maps in it, a few monitoring things, some crash tracking apps and things like this. So there are all these APIs, and those APIs are all built by teams that you don't control. They're all vendors, or they're all things that you consume. So a lot of people now are used to building this idea where I have my trusted team that's building a thing, and then there's this untrusted API-driven world out there that's changing asynchronously, and I just have to deal with the fact that every now and again there's a new version of some API, and it'll happen asynchronously to what I want to do. So what you're doing here is creating a bounded context from domain-driven design ideas that lets you deal with what you want to do. So now, I've got a bit more time, I'm going to talk about how we get there. So the first thing is how crazy does this sound, right? If this is, a crossing the chasm problem, then you really need to start with the Phoenix project. So this is a quote I gave them, which is on the back of the book. So if you're knee-decking alligators and you're trying to drain the swamp, then get this book and give it to all of the executives and try and get them to understand. It's a novel. It's really a horror story about development. It's about everything. The first half of the book is incredibly depressing as stuff goes more and more and more wrong. And everyone will say, oh, that happened at where I worked. Oh, that happened where I worked. So it's full of that kind of stuff. But thanks to the miracle of DevOps and Kanban and all fluffy pink unicorns and things like that, it gradually gets better. And it's got a happy ending, of course. But you will recognize everything in here. And once you're out of the swamp, it's good to hear that Jez is here with the book. So if you think you're out of the swamp and you're just trying to figure out how to speed everything up, then I think Lean Enterprise is a very, very significant book. We're going to be talking about this book a lot this year. I've had access to some of the early versions of this, just proofreading it and things like that. I think it's going to be a very key book. It's out of the whole Lean series, and people have been doing Lean analytics and Lean startups. Now the enterprises are trying to figure out how to do this too. Okay, so you're out of the swamp, you've got some ideas. Which vendor do you go to buy your stuff? Where do you get all your code from to go build this stuff? Well, it's all open source, right? Yeah, you can buy support from vendors, but really almost everything we do now, almost everything that Netflix does comes from GitHub, and the companies I'm talking to, the technology they're basing on is the most advanced, scalable, and stable code you can get is open source code. And those products you used to buy from the big vendors, they don't scale very well, and when they break, it takes forever to get them to patch it, and all those kinds of problems, and they cost a lot of money. So you just got rid of your procurement cycle. That's nice and fast. You can fix it yourself, you can extend it yourself, you can join a community to help something. And then also on GitHub is where you find your developers. So if you want to go and hire the best people for a particular project, you go and see who's the committers on that project, who are the people working, who's active. You can see that publicly because you can see who's forked it, who's putting fixes in, and it becomes a recruiting tool. And that means that the developers are incented to contribute back to projects because that makes them more valuable. And this is tricky because if you're a company and you have your developers, maybe you don't want them to become more valuable because then they'll leave. But also, if you actually are active yourself on GitHub as a company, you start attracting the best developers. And there are many cases where Netflix has acquired some of the top developers in the field because it's got a very strong GitHub presence and a very strong open source place. So if you own or are a major contributor to an interesting project, you want to go work somewhere where that is going to be supported. And then you can go look at, at the highest end, you end up sort of, for the projects that are most critical, you end up sort of getting the Apache committer level people. And And then you can see who's really using stuff. Like if you look at Cassandra, for example, I think there are now 3 of the Apache committers are now work at Apple. So it's probably one of the biggest users of Cassandra right now. But they don't like talking about what they do, but they can't not talk about the fact that they have 3 Apache committers on stuff. Sorry, that leaks out. So you're building this extensible platform. You create an ecosystem around it. There's lots of benefits here. It's very agile. But the other thing is when you're open sourcing your own code, you can try and control it a lot, but really what you're trying to do is ubiquity is worth more than control. So Apache license is the one that all the Netflix stuff is Apache license, everything they consume is Apache license, everything they generate. This permissive license is really important too. Okay, so you can go on GitHub. So which pages should you go at GitHub? Where should you go look for stuff? Well, we've talked a lot about Netflix. So there's 40 plus projects that do stuff. This is basically a highly available cloud-native platform based around stateless microservices, immutable code, instant rollback, all the kinds of technologies I've been talking about, but also automatic deployments, auto-scale capacity, distributed around the world, and these denormalized data stores. So we can go find those projects, but you're going to get technical indigestion trying to keep up with the tech blog. It's really hard work to just keep up with the stuff that they keep putting out there. And as I was trying to get people to understand what Netflix was doing, that was actually the biggest problem, I think. There's just too much of it. So you're hitching yourself to a runaway train or something. I know if you decide to get on this one, you'd better already be able to go fast because this whole thing is moving incredibly quickly. It's not a nice stable release that's going to sit there for a year for you to base on. So that's kind of the good and the bad of it. So I mentioned microservices a few times, so I'm going to try and define microservices. And it is, what's the difference between that and service-oriented architecture, which has been around for a while? And I think that the 2 key things here, one is that it's a loosely coupled SOA. SOA with all those WSDL things and SOAP and all that stuff was tightly coupled, and you ended up doing this sort of global enterprise architecture based on SOA where everything was centrally controlled and managed. So what we want to do here is have a loosely coupled architecture based on REST calls mostly, and use bounded context. And by a bounded context, I mean that everything you need to know is bounded here. You can understand everything about this domain, and that is the microservice, right? You don't really need to understand much about everything else that's going on. As long as you understand who's consuming your service and what it depends upon, you've got this context. And that's a key concept from domain-driven design, which some of you probably read the book on that. So what happens when you do that? And let's try and compare scaling these models. So in a monolithic model, if you want to get some code out, you basically need to get on the train. You sort of buy a train ticket, and you can only have so many people at a time on a train. Microservices, everyone has their own build. They're all leaving asynchronously. Instead of having everyone running this monolith, you just need to run your own bit. So your context, your bounded context is smaller than needing to understand what's going on in the bigger one. There's no waiting, there's no meetings, so it's quicker. You don't have to coordinate for a product release. It's an API call. There's a timeline service at Netflix, and every time you do a push, an entry is made into this timeline. So if everything just breaks, you go look at the timeline. Who just changed something? Okay, go back and revert that last change. It's very fast. But it isn't everyone coordinate and pay a lot of attention. We're just about to make change. It assumes that there isn't going to be a problem. You don't need to learn the deploy process. You check code in, and it flows to production. Instead of copying code to existing servers and replacing the old code, which means that you really have to roll forward, you still have all the old code running. You can have as many concurrent versions as you want, which is also why you don't want to have to explain the state of your system to the ops people, because it's too complicated. You have all these different, you have the old version, that version, this one's in test, this one, the traffic's being routed through them in this complicated way. I know how it works, and if you call me at 3 a.m., I will make the right change to fix it, right? That's what matters. And you can roll forward and back in seconds. And there used to be that done was when you gave your code to QA, and then we've moved on a bit. Now done is when it's running in production, is what people typically think now. But in this model, done is when you remove your code from production. When that line of code is no longer running anywhere in the world, you're done. If you have some of your code running, you own it, right? So you're not done until, so you're incented to remove old stuff from production in case it breaks, right? So that's another incentive the correct way back into the developers, right? Because they're not done while it's still running. So how are we separating these concerns, and how do you structure it? So Conway's law says that the code will follow the communication structure of the organization. So let's set up a communication structure within the organization that reflects the code we want to build. Let's turn that backwards. So you don't try and fight Conway's law. You basically use it as a lever. So you own your own service groups, you own your own back-end stores, you create a team, and you say you can build anything you want within that team, and that team will go and create that. And then the communication network between teams will be the API calls between them. So the size, lines of code in a microservice doesn't really matter. A lot of the Netflix ones are sort of 30 gigabyte RAM on a single VM. They're pretty huge, really. But they do one thing. That's a single verb. It's its own build, so you don't have this trunk conflict. You can build out of old versions of things, new versions of things. You're not trying to manage within one monolithic thing how many versions of the same code can you have. It's a problem. Whereas if you have lots of copies of the code, you can have different versions of things. You need some kind of container, and you can use the Tomcat Java container baked into an AMI is what Netflix uses. Nowadays, a lot of people are actually trying to merge Docker with the Netflix OSS and the other things. It's a nice container. Doesn't really matter as long as you have some kind of container that's moving this code around that becomes relatively immutable within that container. And you're building stateless business logic, so it's a field of cattle, kind of field of servers, and if a few of them die, you can just replace them. So you may have heard of the cattle versus pets analogy. If your machines have individual names and you care if they're alive or not, it's a pet, right? If it's a field of things, and if a few of them die, you just replace them and you don't care, as long as you still have some in the field, they're cattle, right? So think of it like that. And even the stateful data layer can be ephemeral. Netflix uses Chaos Monkey to kill its Cassandra instances continuously to prove that they are automatically replacing themselves, to prove that they can. So it is a totally managed system where the disks within those machines, those stateful instances, are being deleted along with the data. Just to be really clear on that. And as soon as you delete it, there's 3 copies, so the new one comes up and it sucks the data from the other 2 in 10 minutes or half an hour, depending on how much data is on it later. They're back running again, fully triple redundant. But they can run on 2 out of 3 at any time. So what does the development architecture look like? Well, there's this problem that there's this argument you get over whether there should be client libraries for an API. And if you start with a raw protocol, you'll find the first thing that happens is somebody will write some code that talks to it, and then that will become a client library, which they will share with their friends. And you have this slightly broken client library that doesn't really understand your service, that gets adopted by everybody else, and then eventually someone tries to give it back to you to maintain. And that will happen. I've seen that happen everywhere. I get the knowing nods in the audience, yeah. So you have to control your API and control the client libraries. And yes, you might have to write it in a few different languages, but there is an immense strategic advantage from doing that. One of the reasons MongoDB is incredibly successful is that they have a very good set of client libraries for a very wide range of platforms. It gave them an extremely strong start in the market, and it makes them very productive for developers. So that is a huge strength. And sort of looking at that from the Cassandra point of view, Cassandra is sort of easier to deploy and manage at scale, but its client library story was a whole bunch of mixed up open source stuff, and they didn't control those clients. And that was one of the things that slowed down Cassandra in the early days. They're both kind of trying to fix, because MongoDB is working on scaling better, and Cassandra is working on getting better client libraries, and they're sort of all gradually coming back into line. But that you can see, so strategically, it's very important to control that. If you're trying to do these services that call lots of other services, you eventually realize you can't just have blocking calls to them. You have to be multi-threaded. And the whole observable model, reactive model, using observable is a very clean way of doing that. It's really becoming popular now. I'm going to spend more time talking about it, but go look at that. Go look at Ben Christensen's presentations from Netflix, and there's a lot of research and a lot of interesting things happening there now. And then when a service breaks, you've got to be resilient to it. So I gave release it to the API team at Netflix about 3 years ago, and they went and implemented circuit breakers and bulkheads and hystrix. And then eventually at a conference, I introduced them to Michael Nygaard, and they said, we just built all this stuff. And it's all, yeah, finally, right? So we've got those ideas in code that you can just go download and use. And a lot of people are now starting to adopt those ideas much more explicitly. So those work really well. And the Netflix stuff is very, very organized around sort of cloud-based dynamic stuff. If you're more data center-based and you're building your own infrastructure, then Mesos is looking good, and a lot of the stuff that's happening out of Twitter is very interesting. So they're using Apache Mesos, and they have their own sort of microservices model based on Finagle and Zipkin. Okay, I've got a few more minutes, so I'm running out of time. So data stores, I've talked a bit about this. You always end up building a data access layer. Netflix built a prototype one called Stash, which has MySQL and Cassandra behind it, but it turns it into an HTTP access. And you can go add more data. It's pluggable. You can add more in there. If you're worried about CAP and consistency, and most people have been taught that their transactions be atomic and all that stuff, first thing you should do is go and read the Jepson series. Of most databases or systems that you're probably using have been tortured to death by Kyle. You should go read how he tortured them and what they really do and don't do. And then, this is kind of speaking as a physicist, the laws of physics and speed of light and everything. There is actually no such thing as a consistent distributed system, so you should get over it. And if you want to be available, just work out how to avoid needing consistency, because it isn't really there anyway. You just think you have it, and that's why you have outages, right? A lot of the outages. So then there's a couple more things. Great, you've got all this stuff, you want to go build it, and then you go to management and go, yeah, we want to build this, and then the product manager wants you to spend all your time building new features. So how do you deal with that? So there's some strategies here for dealing with product managers. And there's the carrot strategy is, we're going to be able to build stuff for you quicker with microservices. It's like, oh yeah, that sounds good. All right, so go and do it, right? Or no, but we're not going to implement this feature until we finish building our microservice-based system, right? So for Netflix, that was actually, the move to cloud was one of those stick ones where it says, the old database, the old code base was not internationalized, it only did English. The product managers wanted to do rest of world and Spanish and French and all these other languages, and it says we are only implementing that in the cloud, in the new system. So the cloud-based, Cassandra-based system is the only version of Netflix that understands localization languages. The old DVD data center code only understands English. So they said, yep, if you want to do the rest of the world, you've got to let us go and do this cloud thing. And then the shiny object was like, okay, go and worry about PS3 user interfaces instead of the website while we're moving the website, was actually what happened at Netflix. But that's the shiny object strategy. Like, go and worry about, there's a section of this code where I need to stop changing it so I can move it. Go worry about some other piece of the code and concentrate on changing that, and then we'll get to that later and we'll flip back and forth. So that's kind of the shiny thing. All right. I did a presentation a few weeks ago at Monitorama, and I've just got some summary stuff here from that, so I'll go through this pretty quickly. Problems with monitoring this stuff. High rate of change, ephemeral configurations. This machine only exists for a few hours. How do you monitor it for, my graphs want to do for weeks, so how do I aggregate everything properly? Complex calling patterns, you're trying to track everything. And how many of these microservices do you have anyway? So here's a graph of what happens when you convert to microservices from Guild Group. They're on a 450 and heading upwards, and this was earlier this year. Netflix has over 600. You end up with these, what's your architecture diagram? Well, this is actually from that same Guild presentation, and this actually only shows 12 of their services. This is what the Netflix architecture diagram looks like, and this is from a talk from Twitter from QCon London showing their architecture diagram, and I call these the Death Star. And the real Guild Group one with 450 would look exactly the same. So all architecture diagrams turn into a circle of illegible icons with lines between them, and you have to go and figure this out. And you have to stop needing to draw that, and it changes continuously as well, so there is no sort of version of this. By the time you have to go build some tooling to do this. And Twitter seemed to have built some interesting tooling for it, and that's kind of one of those D3 chord graphs or something. So there's a few tools that attempt to visualize it. App Dynamics instruments the JVM and the headers, and you start doing HTTP injection with tags and things. So there's some interesting techniques there. Boundary and CloudWeaver have some other approaches for kind of doing this at the network layer. Or you can instrument your own things. And the Netflix PaaS is instrumented with transaction tags in every request and sub-tags, so you can actually go and construct this yourself. And when you do it sort of built into the platform, you get some better scalability characteristics. Some other implications, changes are smaller, but they're more frequent. Individual changes are going to be broken. You're flipping these feature flags back and forth, so instant detection matters. So how fast can you tell? And I have some slides here on that. If you're monitoring minute by minute, something broke, it takes you a couple of minutes before your agent on the machine even notices, and then it sends it to the monitoring system, and then it gets processed, and then eventually you get 1 point on a graph that's above the line, and you go, maybe there's something wrong, but you need several of them before you're triggering an alert. Otherwise, you get alerts all the time. So maybe like 8 to 10 minutes later, you realize that something's not quite right, and all you did was turn on a feature, right? So, whoop, didn't mean that, sorry, turn the feature back off. So if it takes you 10, 20 minutes to tell that you actually did fix it, or 10 minutes to tell you broke it, and another 10 to figure out you fixed it, it's bad. If it takes you seconds to do that, probably people wouldn't even notice. If you can do stuff in less than a browser timeout, it works pretty well. So let's do that again, except monitoring by the second. So it broke at the same time. We measured it in a second. We saw it as high in a second. It got to the monitoring system a second later. We saw it. And it looks pretty bad, and we're going to go fix it. Oops, sorry, went too far. So, in a few seconds, you can see it. You flip it back. A few seconds later, you know you fixed it. So it's very important that you have ways to get at the systems directly when you're flipping these feature flags on and off. So Hystrix has this thing called Turbine, which lets you aggregate the traffic from lots of different systems and do these 1 second update graphs that show you which circuit breakers are flipped on and off. And that is, your browser is connected directly over it's just sending JSON over a socket. It's whatever you call that. I've forgotten the technology name, but basically, you can connect directly to one service, and Turbine is an aggregator that grabs an entire herd of services and aggregates it into a single flow, so you can see what's happening at that level. But there's no intermediate system, and there's no collection in this system. It just basically gives you, 10 to 30 seconds of history of what's going on. And you can see at the bottom there, that's the difference between a good and a bad bookmark. Now, what is it? It's a circuit breaker flips, and it goes red, and things are bad. There's a couple of products out there that also do seconds, and this is a SaaS service that collects data from your machines on a 1 second interval and aggregates them and shows you what's going on. So you could use those as well. So it's certainly possible to build a back-end service. I don't know any open source tools right now that do 1 second level aggregation and passing on through, because it's actually a pretty hard problem. It took Boundary a long time to build their back-end that can do this, and it's an interesting, just figuring out how Boundary works is actually an interesting thing to go look. So what I'm basically saying here is the latency from something happening to you seeing it needs to be less than, say, 10 seconds. That's kind of, because if you're a developer and you push the button and it kind of looks okay, because if you don't want to push the button, I'm going to wait 10 minutes, let's go get a cup of coffee, and then meanwhile it broke, and you just added another cup of coffee latency to your outage. If it happens, you'll sit there, wait 10 seconds, okay, that looks good, I'm fine, right? You want to be in that, you want to be able to capture the attention span for a change like that. All right, so I'm basically done. This is my summary from the beginning. This is what I learned at Netflix, and hopefully communicated some of that here. And just to summarize it, really boil it down to two things. A lot of this is really about the old thing, separation of concerns, making sure that you can move fast because your concerns are separated, and then bounded context so you don't blow your brain up trying to understand too much stuff at once, right? So that bounded context is really important. So, go and read the domain-driven design book or the Wikipedia page on that to figure out more details on it. But those two concepts applied give you real speed. So that's basically it. And that's my, I don't have time for questions, but There's lots and lots of slide decks. This one I will turn on slide share when I sit down in a minute. It's actually just sitting there. And I've got some more talks coming up. So thanks everyone.